Today, we're diving into the invisible engine that makes the internet feel lightning fast, Amazon CloudFront. I mean, really think about that for a second. You click on a link for a website that's physically hosted thousands of miles away, across an ocean, and poof, it just shows up. How is that even possible? Well, it feels like magic, but it's not. It's actually a really clever solution to a very real physical problem, the problem of distance itself. So, we're going to pull back the curtain and break down exactly how this global network works to bring the internet to your screen in, well, the blink of an eye. Okay, so first things first. To get why CloudFront is such a big deal, we have to understand the problem it was built to solve. And it all comes down to a basic law of physics. And that problem has a name: latency. It's just the time it takes for data to get from point A, the server, to point B, your screen. And the farther apart those 2 points are, the longer it takes. It's that simple. You see, without a system like CloudFront, your request for, say, a web page has to navigate this kind of messy maze of different computer networks all over the world. And every single hop on that journey adds just a little more delay, a little more latency. So, how do you solve the problem of distance?
Well, you can't make data travel faster than light, right? But you can make the journey a whole lot shorter.
And that is exactly what Amazon CloudFront does. At its core, it's just a huge worldwide network of data centers that Amazon calls edge locations. And their main job is something called caching, which is just a fancy word for storing a copy of the content, like an image or a video, somewhere that's physically a lot closer to you. This analogy is actually perfect for understanding it. Imagine the main server is this giant factory somewhere in the middle of the country. Instead of you ordering something and having it shipped all the way from that one factory, the company stocks its most popular items in little local shops in every city. The edge locations are those local shops. You get your stuff way faster. All right, let's follow the data. We're going to trace what happens from the moment you click a link to see how this all works in the real world. So, this is the ideal scenario. It's called a cache hit. You ask for a photo, the internet's address book, DNS, automatically sends your request to the closest edge location. The photo is already stored there in its cache, and boom, it sends it directly to you. It is incredibly fast. But what if you're the first person in your neighborhood to ask for that photo? Well, that's called a cache miss. The local spot doesn't have it yet. So just this one time, it makes the long-haul trip back to the main factory, the origin server, to grab the file. But here is the really smart part. It gives the file to you, and it saves a copy for itself, so the next person who asks gets that super fast cache hit. And it gets even more clever. There's this middle layer, almost like regional warehouses. They're called regional edge caches. They hold stuff that maybe isn't popular enough to be in every single local store, but is still asked for enough that you don't want to go all the way back to the main factory. This just makes everything even more efficient. Now, speed is obviously the star of the show here, but it's not the only benefit. When you build a massive global network like this, you can do a whole lot more with it. And its versatility is just amazing. Yeah, it can speed up images and website files, but it's also powerful enough to stream live video to millions of people at once. And get this, it can even run little bits of code right there at the edge, close to the user, to customize their experience without that slow round trip to the server. Plus, it handles a ton of security stuff too. And think about this for a second. If your main server, that central factory, has a problem and goes offline, it doesn't matter as much. You've got copies of your most important stuff stashed in dozens of places all over the globe. It makes your website incredibly resilient and keeps it online. So this all might sound incredibly complicated to set up, but honestly, the process is pretty straightforward. Let's just do a quick flyby of how a developer gets this up and running. A developer basically just points CloudFront to where their original files are. That's the origin. Then they upload their content, create what's called a distribution, and CloudFront gives them a new web address. And that's it. That new address is now plugged into this entire global network. The system is also really flexible. You can set it up for just one website with its own special settings, or if you're running a big platform with tons of different customers, you can manage them all together in a much more efficient way. So look, if there's one thing you take away from all this, let it be this. CloudFront's job is to shorten the digital distance. It creates a shortcut, bypassing the complex, often slow public internet. And that shortcut makes the web faster and more reliable for every single one of us. Ultimately, all this incredible technology is really just trying to do one thing: get that delay, that latency, as close to zero as possible. And it just makes you wonder, what becomes possible when it actually gets there? When the lag is completely gone? What kind of new things can we build then?